In this lesson, we're going to learn all about translating figures by the use of something we call a vector. So what I'd like you to have out is a pencil and your notes papers so that you can take notes along, and I'm going to ask you to try to answer some questions on your own. To start, we'll look at the letter B. And imagine that this dashed line right here is a horizontal mirror. Now, what I'm going to do is I'm going to imagine what this letter B is going to look like in the horizontal mirror. So the reflection of the letter B. And what turns out is B reflected across this mirror is actually just the same letter. So the question becomes, what other letters in the alphabet can you do this with? So we could look at the letter O reflected across, and we'll notice that O again becomes the same exact letter when it's reflected across. Now you can look at other letters, like let's say capital A. When you reflect that over, it turns upside down. This tells you that the capital letter A is not symmetric about the horizontal axis. So this is kind of an introduction to what you'll be learning in this chapter. And the first term we're going to look at is called a transformation. You've probably heard this term before. Maybe you've heard of the transformers. And I kind of want you to think of the transformers when you think of transformation. It's an operation that moves or changes a geometric figure to produce a different figure. So what happens is you slide, flip, turn, enlarge, reduce, or change how this figure looks. So again, transformers. What do? Well, they change from the transformer into a car and back and forth. There are 4 different kinds of transformations we're going to look at. And in all of them, the original figure that we actually start with is called the pre-image. So think pre, think before. And then what comes out of using the transformation is the image, or the product. And that's the new figure. The first one we talk about is a reflection, which is where you think like the mirror example. You take a pre-image, the original figure, and you reflect it across some axis. And this could be vertical, horizontal, or oriented in different ways. But it's just the mirror image across some line. Then we have a translation. A translation takes the original figure, the pre-image, and it moves it in some direction. A rotation rotates around some central axis. So we have this point in the center, and the pre-image, the first original figure, is now being rotated around that central point. And then finally we have the dilation, which basically takes your original image and blows it up. Think of when you go to the eye doctor and you get your eyes dilated, they get larger. The next term to familiarize yourself with is isometry. And an isometry is sometimes known as a congruence transformation because all that you're doing is moving a shape around in the plane. So for example, moving a puzzle piece around, flipping it over, it does not change the size or the shape, but it changes the orientation. So the question becomes, well, how do we recognize an isometry? If we look at number 1, the star is basically just shifting over. So it's laying on a flat surface and it's being dragged over. It's not changing its size or shape. So yes, this is an isometry. Number 2, we have a rectangle that's just being shifted this way. It's not a straight shift, but it's rotated a little bit and then also shifted over. So yes, this is an isometry as well. Number 3, again, this is an isometry because we have the piece that's just being flipped over and moved. Number 4 is not an isometry. As you can see, the first image, or the pre-image, which is this smaller one here, is being enlarged, so it's being dilated. So no, this is not an isometry. Now go ahead and try number 5 and 6 on your own. We can describe any translation using the coordinate plane and coordinates, so x, y coordinates. And this translation given is going to take any xy value, it's going to add 3 to the x value and subtract 2 from the y value. So let's take a look at what these look like in terms of our homework, which is like numbers 3 through 6, which you will complete. What is the image of 5, negative 1? So this xy, that's the pre-image. And then what it translates over to, this again is the image. So if it asks us what is the image of 5, negative 1, we can assume that that is the pre-image. That's the xy coordinates. So what we do is we take 5, the x value, we add 3 to it, and we take the y value, negative 1, and subtract 2 from it. So this becomes 8, comma, negative 3. That is our image of the original point. Number 2 again is a similar question that I'd like you to try on your own. So if you have to pause the video and try that now, feel free. I'm going to move on to number 3. In number 3 they're asking a different question. They're asking for the pre-image of the coordinate that's given. Notice how it is marked with the C prime. C prime usually means the image, so that prime notation usually represents an image. So we're actually given this in terms of, well, negative 1 is equal to x plus 3, and negative 7 represents the y minus 2. So what we have to do is start from the image and go back to the pre-image. So since we added 3 the first time, we have to undo that operation by subtracting 3. And then again for the y coordinate we have to add 2 since we first subtracted 2. So we can take negative 1, undoing addition is subtraction, so minus 3 for the x value. And since we subtracted, again we're going to add to undo that operation, so negative 7 plus 2. Now my new ordered pair simplified is x is equal to negative 4 and y is equal to negative 5. So you might want to check yourself too. We're saying that negative 4, negative 5 is the pre-image. If I add 3 to negative 4, I do end up with negative 1 as my image in the x value. If I subtract 2 from negative 5, I add up with negative 7, which is again the value of my pre-image. Go ahead and try this last one on your own using the same methods that I just described. Let's take a look at the properties that we just looked at graphically. So we can start with this polygon given, and we want to translate this based on the rules described above. It's going to take any coordinate pair x, y, add 5 to the x, and subtract 3 from the y. So using what we just learned, if a, which represented on this diagram again is negative 4, positive 5 over 4 up 5, a prime, which is the image of a, can be described as, well, negative 4 plus 5 is positive 1, and 5 minus 3 is 2. So I can plot the point 1, 2 over 1 up 2. But now notice what I just did. It says x plus 5, so the x value of a, I added 5 to. 1, 2, 3, 4, 5. And then the y value subtracted 3. 1, 2, 3. So I went over to the right 5 and down 3, getting me to this point. So I really don't have to do the math for all of these ones. I can just ask myself that same question. Okay, b, I want to go to the right 5 since it's plus, x plus, the right 5, 1, 2, 3, 4, 5. And then I want to go down 3. 1, 2, 3. And I plot a point there. I'm going to do the same thing for all of the points. So again, I'm moving over 5 to the right and down 3. Down 3 brings me here. And then lastly, my point D. Now I can redraw this figure, and this will be my translated figure. I do have to label this properly. Since D moved to this point, I'm going to call this D prime. Here's A prime, B prime, and C prime. Now I have the pre-image represented by A, B, C, D, and the image represented by A prime, B prime, C prime, D prime. In this question we're going to put both of the processes we followed in the last two together. So we have points given. We want to find the prime points, the images of the points, and we want to graph both the pre-image and the image. It doesn't matter where you start. You can start by graphing the points A, B, C and connecting that triangle. Or you can take the points and use this transformation given to find the image. I'm going to start by plotting A, B, C and connecting the triangle. It's important that when I plotted this, I labeled each vertex A, B, and C because I have to distinguish between the pre-image, which is now going to be in the red, and then the image, which I'm going to draw in blue. So this translation is given by subtracting 4. That means we move the x value over to the left by 4 units. And then add 3 to the y, that means move up 3. Again, it doesn't matter if you want to do this graphically or just using the coordinate pairs. I'm going to start with the coordinate pairs. So a is given by -1 as the x value. So to -1, I'm going to subtract 4. -1 minus 4 is -5. And then the y value, 3, I have to add 3 to it. So that's 3 plus 3 is 6. My a prime is going to be at -5, positive 6. So I count over to the left 5, 1, 2, 3, 4, 5, and up 6. And I plot that new point. And I'm going to call this a prime, the image of a. For the next ones, it's up to you. Find it however you want. I'm just going to subtract 4 from c, so I'm going to move c over 4 and then up 3. Over 4, up 3 brings me to here. So this is my c prime. And then b again, I'm going to move over 4 and up 3, and then I'm going to label it as b prime. Now I'm going to connect all of those for my image. It's still important that I go through and I label what b prime actually is, so I can look at the coordinate graph and figure out that b prime is located at -8, positive 1, and then c prime is located at -2, 4. Now what happens if you're not actually given the rule for translation? You have to write it yourself. So you have to decide where your coordinate xy is going to. Well, looking at the coordinate graph and the two figures on here, you have an original figure a, b, c. I know this is the pre-image because it doesn't have the prime notation, the little apostrophe. So this figure is going to be translated onto a prime, b prime, c prime. And we have to figure out how. So what I do is I start at a, the pre-image of vertex a, and I notice that counting over, 1, 2, 3, it's moving over to the left 3. That means -3 in the x direction. So I can write that as x minus 3. In a similar fashion, after moving over 3, we have to move up 1, 2. So that's adding 2 to the y. So I can write y plus 2. And that's it. I'm done. We're going to use a vector to describe a translation. And a vector has both direction and size. So when we're looking at this picture, we're going to focus on the vector fg, right here, the hypotenuse of this right triangle. And it's important how this is written. The diagram shows a vector named fg. What that looks like is fg with an arrow on top. It's important that f comes before g, because what this says is that the initial point or starting point of the vector is f. So it starts out at f. This is my starting point. And then it's going to continue all the way until its ending point, g. The ending point of a vector is called the terminal point. Think ending, termination, end of a job, terminator, however you can remember that. And that is point G. So we can describe any distance, direction, and size using this vector. The component form of a vector combines both the horizontal and the vertical components. So to describe this, we take the point F and we move it over 5 units and then up 3. So the component form here would be 5, 3. Notice the little brackets that I used. They're kind of like little angle brackets. They're sharp, sideways turned V's. That denotes the components of a vector to distinguish between an ordered pair. So we're not going to use the parentheses that you've been used to for describing an ordered pair. A vector rather uses these brackets. To name a vector, we always write down the initial point first and then the terminal point second. And the arrow goes in the same direction on top, starting from G, ending in H. It is not okay to write HG with an arrow backwards. We don't do this. We always write with the arrow forward. To find the component form, we first need to start with the x displacement. So start at your terminal point, and we go over 1, 2, 3, 4, 5 units. 5 units in the positive x direction. And then to get to H, our terminal point, we have to go down 2. So that's a minus for moving down in the vertical direction, 2 units. For letter B, based on the orientation, a lot of people are going to write down SR and then put the arrow in the same direction that it's given. Again, relating back to what we just said in part A, we cannot write that. The arrow has to be facing forward. So we always have to look at the picture and start with the end without the arrow. So we start with the initial point R, and the vector ends at point S. So the arrow always has to go from left to right on top. Component form, R moves over 1, 2, 3, 4, 5, 6, 7 units in the negative x direction. So that's negative 7. And then it doesn't move anywhere up or down. So that's just 0 in the y direction. We'll now look at some examples where we're given an initial point and we have a terminal point. And we have to find the component form of the vectors. So that's the form with the brackets is what we're looking for, x and y. So we're going to look at the movement in the x direction and the y direction. We start with p is 4, negative 1, and we end with p prime is 0, 5 in this first example. So we have to ask ourselves, how do we go from 4 to 0? Well, 4, if we subtract 4, we get 0. How do we go from negative 1 to positive 5? If we add 6, negative 1 plus 6 equals positive 5. So what this tells me is, well, these two values that I just came up with here, that's my vector. Component form of the vector, and this is going to be the vector p prime, is equal to negative 4, positive 6. Another way to look at this is take your p prime, your image, and subtract your pre-image. So 5 minus a negative 1 gives me positive 6, and 0 minus 4 gives me a negative 4. We'll do that in this second example. I'm going to actually start with p prime. So p prime is negative 5, negative 8, and I'm going to subtract off p, 4, negative 1. So negative 5 minus 4 is my first entry of the component form of the vector. Negative 8 minus a negative 1 is my second. So negative 5 minus 4 is negative 9. And negative 8 minus a negative 1, that becomes plus a positive, is negative 7. My component form here is negative 9, negative 7. Either way is fine, and yes, you could also graph this, but I'm not going to take the time to graph it when you could just do it algebraically. I'm going to let you try number 3 on your own, and I want you to find the component forms of the vector p prime using both methods, going from p to p prime and going from p prime to p. You should end up with the same answer either way. We'll start off this example by graphing the vertices of triangle ABC, which are given up top. Once you have triangle ABC graphed, connected, and labeled correctly, we have to use the component form of the vector to find this image. So we're going to translate this triangle. And remember, the first component tells us the translation in the x direction. And negative 2 means we move over 2. And then positive 3 for the y component means we move up 3. So now I have my b prime. I can do that for a as well as c. A, I'm going to move over 2 to the left and up 3. Call that a prime. C, 2 to the left, up 3. Call that c prime. Now I'm putting these triangles so that you can see it visually. But you don't have to do that. Now that I've got A prime, B prime, and C prime, I can connect my image points to make the image triangle. The image of triangle ABC, triangle A prime, B prime, and C prime. My last step is to find the coordinates of A prime, B prime, and C prime. So the coordinate of B prime is 1, 2, 3, negative 3 in the left direction, so negative 3 in the x, and up 2. I'm going to write that as negative 3, comma 2. Keep in mind these are coordinates, so I'm using the parentheses rather than the brackets. We can check ourselves by taking the point B which had the x component negative 1, the vector told us to subtract 2 from that. Negative 1 minus 2 equals negative 3. The y component had negative 1. Negative 1 plus 3 is equal to positive 2. So I don't even have to really read it off the graph, and that's what I'm going to do for a prime. I'm going to take a, which had x component 1, and subtract 2 from it. 1 minus 2 is negative 1. The y component of 4, given an a, add 3 to that, and you get 4 plus 3 is 7. And then finally, c prime, you can look it on the graph if you'd like. 1, 2, 3 over in the positive right direction, and 1, 2, 3 up. So that component, or coordinate, is 3, 3. And we're done. All of these examples that I've done in the notes, they match up pretty well with the homework or the classwork that you will do. So please make sure that you took good notes. If you need to go back and recopy something down, pause, fast forward, rewind, whatever, do that and be prepared to graph this on your own when you come to class. You will do one very similar to this question.